These were the solutions for the 6-3 calculator part. So for the one that looked like this was. And remember I said it the other day, but some of you did not do these. You need to make sure you know how to do all of these. So 49 should have been 0.209 and 3.349. Both answers have to be there. 50.673 and 5.607. 51, 1.443 and 1.697. 52, 1.280 and 4.420. 53.389 and 5.891. And 54, 1.363 and 1.777. Valerie. The 5.3 calculator questions. I mean 6.3, sorry. Joey.
Did it say to round to 3?
It didn't. So your rounding could have been different. On the quiz or on the test it says 3 decimal places, which is why I did it that way, but it didn't. So just make sure, the directions on the initial one said 0 to pi over 2, but then I said make sure you do 0 to 2 pi because you want to include that whole unit circle. The other thing to pay attention to is that none of these questions were negative. So remember when they're negative, so let's just say I'll do 49 as though it were negative so that we remember what we're doing. If it said tan of S equals negative 0.2126, then I'm going to treat it as though it's positive first. So I do tan negative 1 of 0.2126 in the calculator in radians. So I do second tan 0.2126, and I get that reference angle, theta prime or S prime, it doesn't matter what it is, 0.2095. If it said to round to 3 decimal places, it'd be 209, or 0.209. And then from there, I want to figure out where tangent would be negative, and tangent is negative in the second quadrant and the fourth quadrant. In the second quadrant, we do 3.14 minus the reference angle. In the fourth quadrant, we do 6.28 minus the reference angle. So I do 3.14 minus 0.209, and I would do 6.28 minus 0.209. I'm sorry? 6.3. 2.9. What? It was in addition to the web assigned questions. It's in the body of the Canvas. Yeah. 6.071. So those are the two answers. That would give you a negative 0.2126. And these ones are the easy ones to check. Like if I do tan of each of these, then my answer should go back to the question. So tan of 2.931, I get negative 0.2138. They're not going to be exact, but as long as they're close, because we rounded, so they're not exact. 6.071, negative 0.2154. So again, they won't be exact because we rounded, but they should be close and they should be negative. Whatever you get as your prime is your, and this could be theta prime equals theta. Whatever you get as your angle is, you keep it if it's in the first quadrant. In the second quadrant, you do 3.14 minus the reference angle. In the third quadrant, you do 3.14 plus the reference angle. And in the fourth quadrant, you do 6.28 minus the reference angle. Because instead of 180 this time, right, we did 180s the last time because they were in degrees. Instead of 180, it's 3.14 because pi is the same thing as radian degrees. I mean, pi in radians is the same thing as 180 degrees.
The answer was positive.
The answer for the angles?
No, when you do the function and take converse thing.
Yeah.
Okay.
Yeah. On the calculator, no, because it could give you a negative angle, but because our reference, it says 0 to 2 pi, I need the answers to be between 0 and 2 pi. I can't use the negative angles. So that's in the future. We're going to learn how to do inverses in the future, and that would be when you would keep a negative. But for now, no. None of your answers should be a negative angle. Any other questions on these before we get into the graph? So again, test is in two parts. This is part of the calculator part. The other one is just like your straight up find the tan of this angle, find the cosine of this angle, and then the arc, length, and area of this sector are going into the calculator ones. So the review says that when we get to the end of the notes today, we'll go over that, but the review does say that. All right, so we are going to finish the graphs of sine and cosine, okay? We are going to do what's called a phase shift today. This is your horizontal shift. We're going to practice the first part, then we're going to do the horizontal shift. This is a review. We already did this on what day was that? Monday? No. Yeah? But this is, no, we did this, your quiz was Monday, so we did this like Thursday of last week, right? Feels like it's forever ago. Steps to graphing without a phase shift or a vertical shift. So this is where we started. We're going to identify the amplitude, which is the absolute value of A. We're going to find the period, which is 2 pi over B. That's where we start. Then we find the key points by multiplying the period by 1/4, 1/2, and 3/4. The first one is 0, the last one is the period. You plot the key points on the x-axis, you mark the amplitude, and then you connect the curve to make the pattern. Sine starts at 0, goes up to the amplitude, down, down, and back up again. So sine kind of looks like an S. And then cosine starts up at the amplitude and goes down, down, up, up. Kind of looks like a C, a weird C, but it kind of looks like a C from the side. Yeah. Sure. So that's where we started. Then we added a vertical shift. So if it was something at the end that said +1 or -1, separate from the trig function, not in parentheses, then it takes my curve and it shifts it up and down. If there was a negative on the front, we flipped it upside down. Like that's all the stuff we've already done. So we're going to do this one together. This obviously has no phase shift, which is what we're getting to next. My A is what? 1, which means the amplitude is 1. The B is 4, which means the period is 2 pi over 4, which is pi over 2. Then I take that period and I start with 0 because that's the first coordinate or the first key point. I take the pi over 2, I multiply it times 1/4. I multiply it times 1/2. I multiply it times 3/4. And then the last one is the period, which is pi over 2. So this stays as my first key point. Second key point is pi over 8. Third key point, pi over 4. 3 pi over 8. And the last one, pi over 2. And then I go to the graph. My first key point is at 0. The second one is pi over 8. The third one is pi over 4. The fourth one is 3 pi over 8. And the last one is pi over 2. Yep.
Is that pi on 3 pi over 4 supposed to be the?
Oh, this one? No. Thank you. No, it's just 3/4. Then I mark my amplitude, which is 1. So I mark 1 and -1. And then I say this is sine. Sine is the curve that starts at 0, goes up to 1, comes back down to 0, goes to -1, goes back up to 0, and I draw the curve. Now the +1 this time tells you I'm shifting everything up one place. If it was a -1, I'd shift it down. If it's a +1, I shift it up. And it's not in the parentheses. That's the difference. So I'm going to take all my coordinate points and shift them up one place. And that curve is your answer. Questions on that one? If it was cosine, I just would have started at the 1, worked my way down, down, up, up, and then shifted it up again. So it's the only difference. Okay, so now here's what happens with what's called a phase shift, okay? A phase shift is the same thing as a horizontal shift. So we're taking our curve and we're shifting it to the right or to the left. A phase shift occurs when you are adding or subtracting something inside the parentheses. So if I take x and I add pi to it, or I take x and I add 2 to it, whatever that is, that's going to be your phase shift. And just like horizontal shifts in every other graphs, God bless you, if you add, you're actually going to shift it left, and if you subtract, you're actually going to shift it to the right. Everything else is the same. I still find my amplitude, I still find the period, I still find the same 5 key points, but after I find those key points, before I put them on the graph, I add my phase shift. So I either add whatever C over B is, or I subtract whatever C over B is. And then I plot those new key points. So here's our new process. Identify amplitude and period, still same thing. Absolute value of A and the 2 pi over B. Find the key points by multiplying by a fourth, a half, and 3/4. First one is 0, last one's period. Then look for a phase shift. So whatever inside the parentheses, I'm going to set equal to 0, and that's my phase shift. Then I add the phase shift to the 5 key points. So if the phase shift is positive, I add it. If it's negative, I subtract it. Then I plot my new key points on the x-axis, mark the amplitude, connect the curve to the match the sine or cosine pattern. I will know they are different because they have something added or subtracted inside the parentheses. That's how I know this has a phase shift. So I start same way. A is 1, which is my amplitude. B is what's in front of the x, or attached to the x, that's 1. So the period is 2 pi over 1, which is 2 pi. This time there's a phase shift. I figure out the phase shift by setting those parentheses equal to 0 and solving for x. So my phase shift is a positive pi over 3. Then I find my key points. So I'm going to take my start with 0.
How do you find a period?
2 pi over b.
Oh.
Take the period, multiply times a fourth, times a half, times 3/4. Last one is 2 pi. This is 0. This becomes pi over 2. This becomes pi. 3 pi over 2. And the last one without the phase shift is 2 pi. Now I take my phase shift, which is a positive pi over 3, and because it's positive, I add it to each one of these. So I get pi over 3. I have to change these to have a like denominator. So this would be 3 pi over 6 plus 2 pi over 6, which is 5 pi over 6. I have to change these to have a like denominator. This is 3 pi over 3 plus pi over 3, so 4 pi over 3. I have to change these to have a like denominator. So this is 9 pi over 6 and 2 pi over 6, or 11 pi over 6. And I have to change these to have a like denominator. So this becomes 6 pi over 3 plus pi over 3, which is 7 pi over 3. Yep. After, how's that?
Does any of the tests be,
They come back. What? After 1 comes back. Sorry?
does any of the tests be multiple choice?
No. Now I plot my new key points. And there is no key point at 0 anymore. So that doesn't automatically start at 0. That's a big difference from before. So I started at 0, the y at 0, the x at pi over 3. I went up to 1. I came down to 0, down to -1, and back up to 0. All right, we're going to do it again. This time it's cosine. My a is what? 2, which means my amplitude is also 2. Absolute value keeps it the same. The b is what? 1, which means the period is 2 pi again. And because there's something added inside the parentheses, I have a phase shift. If I set that equal to 0, this time my phase shift is a negative pi over 4. So what's going to happen to the graph? It's going to shift to the left, so I'm starting before the y-axis this time. We already did the key points of 2 pi from the last slide, so if you want to save yourself some work, it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Like that would be your 1/4, 1/2, 3/4 if I multiplied it times 2 pi. Yeah.
Where did we get the period again?
2 pi over b. B is got a 1 there. There's nothing attached to the x, so it's 1.
Oh, the period. Oh.
Now I want to subtract pi over 4 from each of these points. So from my key points, I subtract because the phase shift is negative. And again, we have to give a like denominator. The first one is negative pi over 4. The first one should always be your key point. Your phase shift. This is 2 pi over 4 minus pi over 4, so this is pi over 4. 4 pi over 4 minus pi over 4, 3 pi over 4. 6 pi over 4 minus pi over 4, 5 pi over 4. And 8 pi over 4 minus pi over 4, 7 pi over 4. So negative pi over 4 means I'm starting to the left of my y-axis. Next key point would be pi over 4. I want to just set the spacing the same. Doesn't have to be perfect. 3 pi over 4, 5 pi over 4, and 7 pi over 4. My amplitude is 2. And this is cosine. So I start at the top at the amplitude. I come down to 0. I go to -2. I come up to 0. I go to +2. Questions on those?
Could you go back to the last slide so I can see the
After they're done copying it down, yeah. I need you to open 2 things on Canvas. Go to Canvas right now, go to the test review assignment and open 2 things. This thing says class kick. I'm not going to actually have you do it on class kick just to save time. I'd rather just make sure we focus on it. I want you to open this one. It's class kick calc questions. This is on your test review assignment. I want you to open this. We're going to go through and review this stuff. And then your test review, the actual PDF. There are 3 types of questions on your test that are calculator. The first is if you're given the angle and you're looking for the trig function, right? And so these, we just use the regular buttons. These are your sine, cosine, tangent. Use the regular buttons. The biggest thing is that all of them have to be in radians. So when we reset our calculator, we're going to leave it alone. We're going to make sure it's in radians. That's what these three are. We'll come back to this in a second. So number 1 says secant of 6.7. What am I typing into my calculator?
1 divided by cos 6.7.
Good. 1 over the cosine of 6.7. And again, I'm making sure I'm in radians. 1 divided by cosine 6.7. And this is 1.0936. It says to round to 3 decimal places, so this 6 bumps up the 3. 1.094. For 2, what am I typing in the calculator?
Tan of 3.1.
Exactly what it says. Tan of 3.14, and I get 0.0034. This time the 4 drops off, and my answer is 0.003. And the last one is cosecant of negative 1.5. What am I typing in the calculator?
A 1 and
1 over sine, and you keep it negative, negative 1.5.
Does the degree
No, these are in radians, so you don't want a degree symbol.
but it has a degree?
Oh, this should be, sorry, this totally should be without that degree symbol. Sorry, I apologize. It should be in radians the whole time.
Are we gonna get one of those?
No, it should be in radians the whole time. The second type of question is if you are given the trig function and you're looking for the angle. So these are the ones that are going to have more than one answer. These are the ones that we use the rules that S equals S prime in the first quadrant, and these are thetas, so you could use S or theta, they're the same. In the second quadrant, we do 3.14 minus the reference angle. In the third quadrant, we do 3.14 plus the reference angle. In the fourth quadrant, we do 6.28 minus the reference angle. Remembering that all students take calculus, because that's going to tell us which ones to pick. And again, these should usually have 2 answers. All right, then comes the reverse. So you're finding the value of theta or s, because it will use either variable, on the interval of 0 to 2 pi. One of the things that was mistaken on the quiz, not on these questions, on the non-calculator questions obviously, was using 2 pi as an answer. But what does the parentheses on 2 pi mean? It means it's not included in that interval. So you could have included 0, but you should not have included 2 pi. So keep that in mind, okay? Not for the calculator part, that's not going to happen. But for the non-calculator part, 2 pi should not have been an answer, okay? All right, so now it says find the value of theta, again, or s, because those are interchangeable. That satisfies the statement, and round your answers to 3 decimal places. So this time I'm doing all the negative ones. Cosine -1, sine -1, tangent -1. And remember, none of those go in the denominator. So if it's a reciprocal function, I do that first, and then I put 1 over the value. What do I do for cosine theta equals negative 0.67456?
Cosine -1 of positive.
Good. Make it positive first. So second cosine 0.67456, and I get that s, or theta, prime, it doesn't matter which one, is 0.8304. So I'm going to keep the 3 decimal places. 0.830. Then I go to my all students take calculus to find which signs match the question given. So where would cosine be negative? Second and third. In the second quadrant, all right, so in the second quadrant, it should be 3.14 minus 0.83. And in the third quadrant, 3.14 plus 0.83. And you get 2.31 and 3.97. And then again, with time, these are easy to check. You just do cosine of each of those. This is negative 0.674, ... And cosine 3.97, this is negative 0.676. They are not going to be exact because we rounded, but they should at least have the right sign. That's important. And it should be, I would say, to the nearest hundredth should be correct. Questions on that one? All right, so for 5, tan of theta is 1.575. What am I going to do? Good. Tan negative 1, 1.575. And I get theta prime is 1.005. I want a positive tangent. Where's that happen? First and third. So I keep it for the first one. And for the third, I do 3.14 plus what I got. And I get 4.145. And again, easy to check, tan both of those. And you should get back your question. Go to 6. Cotangent and a negative, right? So how do I start? Tan negative 1, don't put that in the bottom. 1 over positive 1.8293. And my reference angle is 0.5002, so just 0.5. I want it where it's negative, which is second and fourth. In the second quadrant, I do 3.14 minus 0.5. And in the fourth quadrant, I do 6.28 minus 0.5. 2.64. 5.78. To check those, I would do 1 over tan 2.64, 1 over tan 5.78. Negative 1.8. Negative 1.8. All right, and then 7, what do I put in the calculator? Good. Cosine negative 1 of 1 over 1.7932. And theta prime, 0.979. I want where cosine is positive, which is where? First and fourth. So I keep 0.979 because that's the first. Fourth, I do 6.28 minus that. $5.301. Questions? So again, 3 of each of those. 3 of 1 through 3, 3 of 4 through 7. And then the third type of question is your arc length and your area of the sector. So this is arc length. Again, SOAR. Area of a sector. Area equals 1/2 r squared times theta. And then 9 is like we just talked about what happens if I'm given the arc length and the radius and I want the measure. This is also SOAR. Then comes your arc length and area of the sector using the calculator. So number 8 says find arc length and area of a sector given theta is 120 degrees and r is 9. So the very first thing I have to do is convert my 120 to radians by doing multiplying times pi over 180. So the zeros get crossed through. This is 6, 9, 2, 3. So 2 pi over 3 is theta in radians. My arc length would be 2 pi over 3 times 9. And I could literally just multiply straight across. 2 times pi times 9 divided by 3. 18.849. That's going to bump to 85. And then area 1/2 9 squared times 2 pi over 3. 1/2 times 81 times 2 pi over 3. And again, I can multiply straight across. 81 times 2 times pi divided by 2 times 3, or 6. And I get 84.823. This time it'd be centimeters squared. And then 9 is working backwards. Find the measure of the arc given the length. So we're given S is 12.5. We're given R is 3. All I got to do is divide by 3. And it's already in radians, so I'll leave it alone. The unit there would be centimeters because it's length. No, measure, sorry. So it would be 4.167 radians if it wanted a unit of measure. All right, this has everything. So the class kick part just has the calculator part, which we're going to go to next because that's been the thing we didn't get quizzed on. But then this PDF has everything, the calc part and the non-calc part. So in the beginning, we're talking about, can I draw the angle? Can I determine which quadrant it's in? Can I find coterminal angles? Okay, these would be without a calculator. Then it gets, so coterminal plus and minus 2 pi. Really, that's what you need to know there, okay? The converting from degrees to radians, if I'm going from degrees to radians, I'm taking theta and I'm multiplying it times pi over 180. If I'm going from radians to degrees, then I'm going theta times 180 over pi. Notice that everything that's highlighted in that like red-orange is what's on the calculator part. So, all right, so we left off at arc length. Remember that those are in the calculator section. So if it's highlighted in that red-orange color, then it's calculator section. Arc length is your SOR. S equals theta times the radius, and theta has to be in radians. So like on your quiz, if it's given to you in degrees, you will convert it to radians. The only difference is on the quiz, you left it in terms of pi. On the test, you'll actually multiply it out. Area of the sector was next. This is area equals 1/2 radius squared times theta. And again, theta has to be in radians. So if it gives it to you in degrees, like this one does, you've got to convert it into radians and then multiply it out. And then the last one there that's underneath it, you're working backwards. It says find the measure of the central angle. So we're finding the measure of the arc if your arc length is given. So you got to work backwards to find theta in radians. You don't have to convert it, but you do have to use the formula in the reverse. So it says the measure of the central angle, right? So that's theta. That's what we're looking for in radians. So we don't even have to convert it back. If the arc length is 23, arc length is S, and the radius is 7, so that's the R. So if SOR is the formula you would use, arc length is 23, theta is what we don't know, and R is 7. And then you'll just divide by 7, and you'll keep it in decimal format. That's really awful, but 3.286. No, it's in radians. The formula gives it to you in radians. If it said degrees, then you'd have to convert it. But it's asking for it in radians, and the formula, that theta is in radians. You're welcome. Then came all the reference angle stuff based on your unit circle. You will be given your unit circle, but this is without the calculator. So this is just like your quiz. Okay, this is where you're given the angle and you've got to find the trig function. And then on the bottom of this is the reverse when you're given, and it could be value or values. When you're given the angle, the trig function, and you're looking for the angle also without a calculator, also using your unit circle. It does say exact value, but remember that there can be more than one answer here, especially like with D. You're looking for all the times that tan is +1 or -1. So that's going to actually happen 4 times. That's straight unit circle questions. That would be on the non-calculator part. Yep.
Exact value, you have to put it in the calculator?
No, exact value would not be in the calculator.
Okay, so
As soon as you put it in the calculator, you round it. That makes it not exact. Yeah. So this means like pi over 4. That's your answer.
Okay.
Yeah.
And for C, there would be 2 answers.
Actually, that's the only time there could be one answer because y is only -1 once.
Yeah.
Yep.
But then for D, there's like.
There's a 4.
Yeah. Okay.
Yeah, because tan happens +1 twice and -1 twice. Yep. These last ones on 6-4 are what we just finished, so you can cross through number 77 because that has a phase shift, but the rest of these are fair game. You can have an amplitude adjusted, you can have a reflection, you can have a vertical shift, you can have a period change where you have a B. All of those you'd want to be able to graph. Yep.
What makes 77 so different from the other?
Because of the adding or subtracting inside the parentheses, it gives it a phase shift. The phase shift won't be on this test. Xavier.
What do you mean by reflection?
Like the negative on the front, right? This flips your cosine upside down, like that. So instead of it doing this, it flips upside down and does that. Yeah. Okay, and then the calculator portion at the bottom. So this is how you'll start. This is the kind of questions that are also on that class kick. So there's 2 ways for you to practice this. I will post the answers to the class kick on this video. So if you want to start there and check them, you can. These will also be, I think most of these answers are already on there, but there's a couple I have to add, like the calculator portion we have to add now that we've tweaked it. These are literally 1, 2, and 3 are using your regular buttons, either the sine, the cosine, or the tangent. For sine, the first one, you type it in exactly that way. You just have to make sure your calculator's in radians. For cosecant, this would be 1 over sine of 3.15. And for cotangent, this would be 1 over tan of 0.46. And then the 4, 5, and 6 is the way we started the class. So I would do sine -1 of the positive version of this number. That's going to give me S prime. And then I locate where sine, in this case, is negative, which is 3rd and 4th quadrant. And I do 3.14 plus what I get, and I do 6.28 minus what I get. For the inverse ones, you hit the -1 buttons first. Remember, the negative ones never go in the denominator. So this would be sine -1 of 1 over 1.256. And this would be tan -1 of 1 over positive 1.27. That's going to give you your prime. That's going to be your reference angle. And then for 5, you're looking for where sine is positive, so 1st and 2nd quadrant. And 6, you're looking for where tan is negative, so 2nd and 4th quadrant. Your goal is to finish the 3 questions on the sine, cosine graphing homework that's due tomorrow, and then get through as much of this review as you can. Maybe hold off on the graphing one since you're doing it in the other assignment, but do all the rest so that tomorrow when you come in, you know what you have questions on. Questions for me before that bell rings? All right, then came